Hello programmers. Well, actually, there's a little hidden example in the loops section, so we're going to have this be called Loops Super Alpha Turbo Hidden Property Lesson. And after that, we're going to do factorial. We're going to write some TDD on that. And so this test that I've just turned on is skips properties of the object prototype. Remember I was mumbling something about has property or has on property? Well, it turns out in 3rd edition ECMAScript, third edition is basically the one that's quite compatible with all the earlier versions of IE. And if you want to know if the current object has a property, and if it's not coming from the parent or prototype, you can check it. That's what we're going to do in this test. If you go up and take a look here, so here's an alphabet that, now just pretend this is an object hash. So alphabet prototype has A and B, alphabet has A and B, and then alphabet's prototype has C. So when you run alphabet and you pass it in, you pass in this object, you're expecting to get A and B, but it's also including C. So this is our little thing. So up here, we just add a little check if object dot has own property. So this is like saying, is it my property or is it my parent's property? Because if it's theirs, I don't want it. Thank you very much. Yeah, whatever. Boom. No problem there. Okay, so let's put a little note. For all those that like old Russian writers, or maybe not Russian, British writers. I'm thinking of, who is it, Kremsky? Anyways, off topic. Let's get to factorial. So we're going to do this. It computes a factorial function. We're going to pass in. And there. We're going to just kind of duplicate this piece of code. And set up that. Just for giggles, we're going to put the comma on the first line. Okay. So, we're going to make a factorial function. So, expect factorial of 0. Oops, I really want to type 9, it seems. Where's my 0? There it is. To 2 equal 0. Yeah? The factorial of 0 is 0, that's right. So, ten. We have 10. We have 5. We have 2. 2 is easy. 2 times 1 is 2. 5. 5 times 4 times 3 times 2 times 1. And 10 should be 5. Factorial should be 10 times 9 times 8 times 7 times 6 times 5 factorial, which is 4 times 3 times 2 times 1. There we go. So we set up our little tests, and I'm not liking my comma living in space there, so I'm going to put it back up on the line above it. And there we go. Okay, computes the factorial of 0. Factorial is not defined. So we're just going to throw this in our loop spec because this is part of our loops. Var factorial. Now it's a good time to mention, when I'm just declaring var function and all these little test cases, I'm actually just dropping functions into a global namespace, which can cause a bunch of issues if you start to use names over and over again. Sometimes it's nice to have a little object, like we'll call it ram 9, and then we'll say ram9 dot factorial. You might have your own version of factorial. So what does that mean here? Well, it means where we call factorial we should actually call that one to be that one, that one, that one, and that one. They should be all those. So let's see. Okay. Boom. Missing comma before statement. So look at that. And what have I done wrong here? Can anyone see? Yes, I named it after the French fashion company. There we go. So, there's another way to do this too. It's all a matter of taste at this point, because both of the two were the same. And whatever is easier. Okay. So now I have a little namespace function, and I'm not bleeding my factorial into everyone else's factorial. And I know that it needs an argument, so a number to factorize. And I'm going to write a little comment here. There we go. And you're probably wondering, what font is I using? That's just simply New Sans Mono. New Sans Mono. And the italic version of it is handwritten. Isn't that adorable? I think so. So, there we go, nice little comment. I got my factorial function all figured out. Number to factorize, return number to factorize. Boom. Computes the factorial of 5. Nope. Computes the factorial of 10. Nope. So it worked for the first two, but not for the last two. So, I mean, if I want to do this the easy way, I could do it like this, dot apply. Actually, I could do ram9 dot factorial. Number to factorize -1 times number to factorize. Oh, too much recursion. Number to factorize minus 1. Ah, right. If number to factorize, what happened? You're probably wondering. You're like, what happened? What happened? What did he do? What did he just do there? He's calling the function that he just declared, and he's minusing 1 from it. Well, what happens when it gets to 0? Well, it goes to minus 1, it goes to minus 2, it goes until basically it runs out of space. And number to factorize. So, but we need it to be for 0, so return 0. Return 1. No, return 0. And there's also another case if number to factorize is equal to 1. Return 1. How do I know this? And I just want to change these loops to my preferred style for the sake of avoiding errors, as I sometimes forget to put double equals. Boom. Done. So what we've just done is we have a recursive factorial. Let's use a function closure. It just looks like I wanted to make it a little French. Excuse me. There we go. Too much recursion. Return recursive factorial. I accidentally discovered a bug, so I'm going to put that bug into my test case. You're wondering what the bug. That should be also 0. So I can check this like this. There we go. Test is fixed. Okay. So let's walk through this code real quick. Recursive. I declare a base condition. Multiple base conditions actually in this case. So if someone passes in 0 or nothing, that's 0. And then if what's passed in is ever 1, that's 1. And then I just say, okay, run yourself on one smaller. So it's just going to keep running on a smaller and smaller number, and then whatever the result is, it's going to times it to the current number. And since it's going to return the current number times the smallest number, what it's actually going to do is go all the way down to 1, return 1 times, it's going to actually go all the way down to 0. No, it's going to go all the way down to 1, and then it's going to return 1, and it's going to turn 1 times 2. And then it's going to turn 1 times 2 is 2, so then it's going to return 2, and so that'll be 2 times 3, then 3 times, so then that result is 2 times 3 is 6, so 6 times the next smallest number was 4. So basically you end up with a little stack which goes like, if you pass in 5, it's 5 times 5, it's actually 5 minus 1 is 4. 4, so func This is our recursive factorial. And then it's going to go in again. It's going to be 3 times 4 func 2 times 3 func 1 times 2. And it's going to stop when it calls func 1. It's going to get this little thing here on line 62 to return 1. And then it's basically, what it's really doing is it's really a chain of this whole thing. It's as if, in memory, through the process of calling these functions, it ends up generating a sequence of calls that looks something like this. That's recursion in our case. Recursion has to have a base case. Well, does it have to be recursive? No, it doesn't have to be recursive. So let's call this iterative. So we're going to have an iterative factorial. I return 9, just for the heck of it. And then I'm going to put, there, I'm going to change my little wrapper. Okay, so expected 9 to equal 0. So let's get it passing first test. Easiest way. Boom. But didn't work for 2. Number 2 factor is, okay. Okay, so enough of that playing around. What we really want to do is calculate a sum. Sum and var sum equals 0 starts with 0. Okay, so if the number to factorize is 0, while if, so let's do a for loop. For var I equals number to factorize, and that's good. And while I, so as long as I is greater than 0, take I and minus from I. Make sense? So as long as we can, as long as we don't have 0, in this case, if the sum is 0, if you pass in 0, it's going to be, 0 is going to be the number to factorize. I is 0, so it's not going to do this loop. If it's 1, it's going to do this loop once. So then sum, actually it's not a sum, it's a product in math speak. Yee, math speak. Okay, so we have a product which is equal to product so product is equal to number to factorize. Let's say that's currently I, so I times what? Well, in this case, we really want it to be like I times 1, we want it to be I times product. So let's have a little check in here. Product needs to be 1, and then let's have a guard clause. If number to factorize is false, then return 0. This is a guard clause. It starts, a guard clause is anything, an if condition immediately at the beginning of a function. So you might have a couple guard clauses, and then you actually have the body of code. So it prevents me from getting into an uncertain state. So number to factorize, return 0, var product 1, product equals I times product. Let's run our test. It's been a little while. Is empty. Loop is not defined. So I have a typo. Missing a bracket somewhere. It's on line 64. Product equals I times product. That's it. Okay. Computes the factorial of 0 if no argument. So first I want to fix my spelling error. Okay. Expected 1 computes the factorial of 0 if no argument. Expected 1 to equal 0. So let's look at that test. Loop spec 126, 126. So the undefined test. So if number to factorize doesn't exist, return 0. And then expected, let's see, loop spec line 126. Expected 1 to equal 0. So it got 1. How did that happen? Number to factorize. If not. There we go. Okay. Boom. So it worked. It just so happened that it worked because I know how to do this one. So I times product, and each time I is decrementing. So it starts out, you pass in 10. It will work, it will get past this guard clause because it exists. So this guard clause is going to return 0 if it's 0, or if it's undefined, or if it's null, and it's going to just be 0. Otherwise, for any value from 2, even for 1, including 1, it'll enter into this loop and it'll execute. So it'll enter into this loop and execute. It'll do 1 times 1 is 1. And then it'll minus 1, it'll get 0, and it'll leave this loop and it'll return 1. Now if the number's 10, it's going to decrement this, it's going to run this loop. 10 times 1, and then that's going to be 10, and then it's going to run 9 times 10, and that's going to be 90, and then it's going to run, it's going to keep running this loop, and as it decrements, this is the iterative way. So here's the recursive way simpler to write, kind of easier to understand if you know recursion, and then here's the iterative approach that operates without creating space on the stack. Because each time you call a function call, you end up with a layer of function calls, so there's different trade-offs going on. None of that really matters right now. All that matters is our test pass. We have correct code, and we have 2 different correct ways to do it. And if you ever need to optimize, you get an opportunity. Believe me, you don't have to do it early. Thank you very much, and goodbye, programmer.